Hello everyone, welcome to IT5008 second tutorial. Without further ado, let's get started. Here is the schema of our current database. You actually need to follow all the instructions in tutorial 1 in order to get into this. And this is quite important, so make sure to do tutorial 1 before 1A. 1A asks us to print the different departments, right? So if we pay attention, you'll see that we have actually this relation, this table called department. And within this department, there's a column called department. And this is exactly what we wanted. So the answer is quite simple. You just need to select d.department from department D. Print the different departments here. Let's move on to 1B. 1B, print the different departments in which students are enrolled. This one is also quite straightforward. You just need to go to this student table and we'll search. Oh yeah, there's a department column here. So it's quite straightforward as well. You just need to select the department from this student table. But wait a minute. If you actually run this query, right, you'll realize something. So this is the screenshot of what happens after I run this query. There's one issue here, which is there are duplicates. Look at this. IS, history, history. And this is not what we wanted. We want it to be unique. We don't want duplicates here. So how can we actually fix this? The solution is quite simple. We use distinct. So after we add this keyword distinct, it will guarantee that the result that the database output won't have duplicates. And this is exactly what we wanted. And this is our solution. So now let's move on to 1C. Print the emails of the students who borrowed or lent a copy of a book before they join the university. The question is asking us about the emails of the students who has borrowed or lent the book before they join the university. So what's the condition here? I want to find a group of students, but this student, it has to fulfill these two conditions here. The first condition is the student has to have borrowed or lent a copy of a book. And the second condition is this group of students must have borrowed or lent a book before they join the university. We only want students who have fulfilled these two conditions. From this, you can write down the condition here. Has borrowed or lent a copy of a book. Okay, you want this student email to be a loan.borrower, or this student, it must be an owner here. And at the same time, the student also need to borrow or lend before they join the university. So after you know these two conditions, right, it's actually pretty easy for you to derive the solution here. Please remember that to put the distinct here to avoid duplicates. If your answer is not the same as mine here, no need to worry, there are also other correct solutions too. So now let's move on to 1D. The same thing again, try to identify what the question is asking. There are a couple of stuff here. The first one is the duration. So if we look back to our schema, right, we realize that, wait, there's actually no duration here. How can we derive this duration? So let's think about it. If we take the return and you minus the borrow and we add 1, this will be the duration. The reason why we add 1 here is because both return and borrow are dates. So, mathematically we should add 1 here. This is your answer. Remember to order this thing as well. Quick question for you guys. What will happen if we remove ASC? Will it output errors? So if you try it out, right, there's actually nothing happens. The database management system will automatically assume that you are using ascending. So it's okay if you don't write this thing here. The query will still work just fine. But I'll suggest you to write it down so that it provides more clarity. If you still remember, if the book has not been returned yet, right, the return column will be null. Duration is equals to return minus borrow plus 1. And if our return is null, the duration will become null minus borrow plus 1. And what would be duration in this case? How can you use a null to minus something? What would be the result? Will we take null as 0? Will it take null as a random number or how? In a database system, when there's a null inside a mathematical operation, the result will still be null. And this rule does not only apply to minus, it also applies to multiplication, addition, and division as well. So if this thing is maybe like plus, multiple, divide, the result will still be null. So how can we actually fix this? We can use this thing called Colisi, if I pronounce it correctly. So what does this Colisi is doing, right, is it substitute the null value with some default value. Formula is something like this. If you look at this query, right, if the return is not null, it means that the book has been returned. So we'll take the return date minus the borrow date plus 1. But if the return is null, and we cannot minus, right, because if we minus, then it will turn to null. So instead of taking null, we take the current date here. So we use the current date, we minus the borrowed, and we add 1. And this will be our new duration. Oh, by the way, I think this one should be descending. Of course, we still have a lot of ways. One of them is using the case method here. Yeah, you can take a look at this. So now let's move on to 1E. 1E wants us to do is, for each loan of a book published by Wiley that has not been returned, print the title of the book, the name and faculty of the owner, and the name and faculty of the borrower. This is quite tedious, I understand, because it has a lot of tables in it, and you need to connect this and connect that. But it's certainly doable. It's definitely doable. You just need to spend more time comparing them. So this would be your answer here. And some of you guys may have different answer from me because you guys have probably put in the copy tables here as well. But actually we can omit the copy since the values is already guaranteed. Because when we are designing this database, right, we already set the values to be identical. So it's already guaranteed by the design. So it's okay to omit copy in this case. I remember one of you asked me what is algebraic queries. So technically speaking, all simple queries are also algebraic. But in this tutorial, we refer the explicit use of joins, union, intersect, accept as algebraic queries. Okay, so now let's move on to 2A. So this 2A, right, is actually the same as 1E, just that instead of using the where, we now need to use the inner join. So before I give you the answer, let's take a look at an example. We have this customers table with this customer ID and a customer name. And with this another table, which is games, we have game ID, game name, customer ID. So the customer ID in this games table is actually referring to this customers table customer ID. So right now, what I want to do is, I want to see the customer name and the game name side by side, which means that I want a customer name on the left side and the game name on the right side. I also want that the game name to be League of Legends. I think this is quite straightforward. So what we need to do is we just select this customer name and then we select the game name from these two tables. And then we just need to compare where customer ID equals to this customer ID and the game name is League of Legends. So we need to understand there's actually quite a little difference between these two conditions. If you look back to this, the green one is our first table, and the games G, the one in yellow, is actually our second table. And this C.customer ID equals to G.customer ID. This one is a key. This one is a key where two tables are able to merge together. And I call it as the merging factor. It's basically the common column of two tables, which allowed these two tables to merge together. And we have the last one, which is the actual condition, the actual thing that filters out something. I want the game name to be League of Legends. This one is to filter out. I don't want other game names. I just want this. Actually, right, I think some of you guys have already realized that even these two falls under the where clause, but they serve different purposes. One serves to merge two tables together, while the other serves to filter out. If you understand this, right, it's very simple for you to convert from this select where to inner join. So just take a look at this. Customer C, this is our first table. Inner join, this is our second table. On, this is our merging factor here. And this one where is our actual condition here. So if you understand this and you are able to convert from select where to inner join, then it's actually not a problem for you to solve this question. Since we already have this solution, right? This solution is from 1e. What we need to do right now is we just need to convert it from this select where into inner join and on. Before going further, right, let's talk about sets operations. So right now we have these two sets here, set A and set B. So let's talk about A or B. A or B is actually A union B. What it means is, as long as you fulfill one of the conditions, either A or either B, you will be accepted. And for A and B, it means that you need to fulfill both A and B to be selected. So it will be this intersection here, because you need to fulfill both A and B. And for this, A accept B is when I want A, but I don't want B. As long as you are B, then I cannot accept you. After you know this, right, it will be way easier for us to solve the remaining problems here. So let's see 2B. We need to print the emails of the different students who borrow or lend a copy of a book on the day that they join the university. We can see there's a or here. So we want the student who has borrowed a book, or we want the student who has lent a book. We can actually separate this thing into two parts. The first part is the students who borrow a copy on the day they join the university. And this is its query here. At the same time, you also can find the students who lend a copy on the day that they join the university. We can actually see this thing as A, and we can see this as B. Since it's all right, what we can do is actually, we can just merge them together. Because if you have borrowed a book, you're part of what we want, right? If you have lent a book, you're also what we want. We need both. We need both here. We can just, first, we select this borrow, and at the same time, we just select this lent here. And we union them together because both of them are what we wanted. So now let's move on to 2C. We are using AND here. Right now, this student must fulfill both conditions. It must have borrowed a book on the day that he or she joined the university, but at the same time, he or she also needs to lend a copy on the day that he or she joined the university. So in this case, it will be the intersection here. Instead of union, we change this into intersect. And this is your query, this is your answer. Let's see 2D, right? We need to print the emails of the different students who borrowed but did not lend a copy of the book on the day that they joined the university. I only want the students who only borrow but not lend any copy. I don't want B, but I want A. So in this case, we can just use this accept here. So let's move on to 2E here. We need to print the ISBN 13 of the books that have never been borrowed. This one is quite similar to 2D. You just need to accept it and you'll get the answer. Or there's another workaround as well, which is left join plus is null. So what you need to do is we take this table and we left join this. If there's a book B here and loan doesn't exist, right, loan will become null. So what you need to do is we just pick all those where loan is null. So beside this union, right, there are actually alternative answers as well. So instead of using union, we can just select A or select B. There's a or here. Remember to put the distinct to because you want to avoid duplicates. And for 2C, it's quite similar as well. We want A At the same time, we want B, the students who fulfill both A and B here. Also remember to put this thing, otherwise it will have duplicates. So now, another thing that I would actually like to add on, right, is the union and union all. So union, what does union do? Union actually removes all duplicates, right? And union all actually keeps all duplicates. So if you look back to this, we have this thing is actually equivalent to the A union B is right here. This is our union method. And this is our distinct method, select distinct method. So what happens if we actually remove this distinct? What will happen? When we remove this distinct, it will be equivalent to this union all, because union all keeps all duplicates, right? This is something for you to add on so that you know that what's the difference between union and union all, and what would be different if you forgot to add a distinct there. So before I end this tutorial, right, I remember that someone asked about what is a view in the tutorial yesterday. So a view is actually a virtual table in SQL that's created using a query. It does not actually store the data physically like a table. For example, if you want to work on something that's quite often, but you don't want to create a table for it, we can use view here. And another thing that I think that's quite important, which is the differences between view and table, is that the view is not always updatable, especially when the views that contain aggregations, right, like sum, average, counts, this kind of stuff, right, they are usually not updatable. In fact, right, it's very, very rare to update directly from the view. So another question that I got in this tutorial is, what if we forgot the brackets in a predicate? What would be the hierarchy? And I would like to clarify something, right? I mentioned wrongly. I said that it's from left to right, but after I checked, right, it's not. In SQL and most programming language, right, the AND operator actually has higher precedence than OR. This means that AND is evaluated first. For example, look, so X is true, Y is true, Z is false. So we just need to substitute all this thing here. X is true or Y is true. These two things will be evaluated into true. And Z is false, right? So true and false is false. What if we forget the bracket here? X or Y and Z. So it will be true or true and false. But in this case, N has the higher precedence, right? So Y and Z will be processed first. So true and false. What is true and false? True and false is false. So right now, true or false, because this thing is false, right? True or false is true. So if you forget to put your brackets, it might lead to unexpected results. In my opinion, it's always better to add more brackets. It makes everything clearer, and it also avoids a lot of unexpected errors, just like this one. So that's the end of the tutorial here, and see you next tutorial. Bye bye.